computer. So to remind you guys again that we do have your test. So your test 3 is this coming Wednesday from 2 to 3:30 in CLA 116. It will cover chapter 6 and 7, 7:1 to 7:3, 6:6 to 6:1, 7 to 7:3. There are around 10 to 12 questions. Consists of calculated and non-calculated part. The calculated part is only consists of 2 questions, so it's really short. So I recommend you to do that one first. Majority of the questions is in the non-calculator piece, so make sure you guys concentrate more time on here. So mostly 10 minutes on the calculator part, 10-15 minutes, but mostly an hour each on a non-calculator. This is new from last week, so those just want to point out to you guys that you are allowed to bring 1 page of note, only front page, only size of a normal size paper. Okay, just a page of notes, any notes you want to put in there, formulas, examples. You can type, you can write, you can do whatever you want with it. So make sure it's front page only. And the review test 3 is over here. So I would recommend you guys to practice the review test 3. As you know that your review test 3 is very similar to your test 3. Okay, so that's one. Questions, anyone for me? Next, we're going to talk about is your online homework. Your online homework that is due this coming Tuesday, tomorrow by midnight, will be 7:2 and 7:3. Okay, so these are the 2 sections that will be due this coming tomorrow by midnight. We did 7:2, which is proving your identity. So now we're going to talk about 7:3, how we solve a trigonometric equations here. So so make sure you guys know the difference between solving equations and proving identities, because a lot of students get those 2 mixed up. So so that is something that I will point out again here. So I think it's this one. Yeah, should be this. So let's talk about the proving identities. And so what we talked about from our last week class, when we verify or prove your identity, please do not solve this kind of equations, or we call it identity. Solve means you don't add tangent x, or you don't add 1, you don't cross multiply, or oh, this one I just multiply this to that side and try to prove or solve. If you do such thing when I want you to verify, you will get it wrong. So just to let you guys know, do not do that. So what we're going to talk about in this section 7.3 is you have to solve the trigonometric equations. So this is solving trigonometric equations is very similar to solving equations. So when you solve an equations, usually we use techniques like combine like terms, factoring. Okay, we try to make the trigonometric functions on one side of equations. Then now the new one is we use identities. Okay, so like when you guys, if you remember how you guys solve log and exponents. So remember back in chapter 5 when we say 3 plus let's say e to the 2ex equals to 4 example. Remember how we solve this kind of equations? We want to make this ex by itself. So I will subtract 3 and then I divide by 2, right? So the ex is by itself. So this is the same type of questions when we do log, is a log, sine or cosine or trigonometric. Is instead of this, we will get 3 plus 2 sine x equals to 4, for example. So last time over here, we subtract 3 divided by 2. This is also the same type. We want to make sine x by itself. So I will subtract 3 and then divide it by 2. Same, kind of the same thing what we did. So this is 1/2. So this, you still get 1/2 here. So the only thing is, like last time in here, in order for you to solve for x, to get rid of e, you move your e over. So your E in this, when you move your E over, it become ln, right? This is what we did in chapter 5, because exponents and log are inverse to each other. So, but for this trigonometric function, where we do sine, cosine, and tangent, and the rest of it, when you move the sine over, it will become the arc sine of it. Okay, so make sure you guys knows that like last time we moved E become ln, now we move like sine or cosine or tangent or secant. When you move it over there, then your arc sine will be your sine will become arc sine or arc cosine or arc tangent. So this is one thing you guys need to know, and you also need to know what is arc sine of 1/2. Can someone tell me what angle will give us 1/2? Unit circles, anyone?
30.
So this is 30 degrees. Or in radians, it will be pi over 6, right? Okay. So so this is what you guys, so first you need to know the basic of solving equations. This is called the basic of solving equations. And then the second you need to know is make sure you also know that what is the arc sine or arc cosine or arc tangent of a certain value. That means your answer is in angles. So so that second thing. Now, as you know that you guys learned the arc sine, arc cosine, and arc tangent, right? We learned that already. So that's why you got the 30 degrees of pi over 6. But what happens when you got cosecant or cotangent? So example is like this. Sorry, not. So example is like cosecant x is 2, because we don't do the inverse cos. I mean, you can, but we don't learn that. So we know that cosecant, the reciprocal is sine. So what do we do here is I can change the cosecant to become sine x, but make sure you know that you have to flip this. Okay, so make sure you flip flop your fraction. So if you got secant, cosecant, or cotangent, you can flip you can do the reciprocal of those, sine, cosine, or tangent, but make sure you flip flop the value that you have there. Okay, so this is the next thing that you guys need to know about this. So and then when you move it over here, then we get the arc sine of it. Okay, if you guys can do the arc cosecant of 2, which is good if you know arc cosecant of 2 is the same thing as arc sine of 1/2. Okay, so so if you have anything that is not sine, cosine, tangent, the reciprocal, you can actually flip flop it. So this is the next rules you need to know. And then there's a lot of other rules that you need to watch out here. So one of them is we need to know the reference angles and the quadrants. Okay, so sometimes when you guys give me this answer that you gave to me is only belongs to quadrant 1. Okay, so depends on what kind of domain they use. So if the domain is from 0 to 2 pi, this means that it goes 1 revolution. And if a question is asking us for an infinite solutions or infinite ways of infinite solutions, then this goes to infinite revolutions. Okay, so so let's talk about 1 revolution, and let's talk about infinite revolutions here. So how do we the question will tell you if it's infinite or 1 revolution. So if a question like this is asking us to solve each equations in radians, means they want it in infinite solutions. So that means you have to go infinite times. But if a question wants you to write in the interval from 0 to 2 pi, means this is only go for 1 revolution. Okay, so make sure you read the question carefully in your homework or in your test, what kind of solutions you have, infinite or 1 revolution. So if you talk about 1 revolution 0 to 2 pi, then majority of your answer here you have 2 answers. Okay, the reason why you got 2 answers is because if you go for 1 full circles, you remember that all students take calculus. So sine is positive for this example in quadrant 1. That's why 30 degrees of pi over 6 is in quadrant 1. And do not forget that sine will be also positive in quadrant 2. So you have to give me what is the angle correspond to 30 degrees of pi over 6. So anyone know what is that angle is in quadrant 2?
150.
And what is that in radian?
5 pi over 6.
Yep. So in this case, that's why I say it can have two answers, because sine is positive in quadrant 1 and 2. That's why you give me two answers. And what happens if you have a negative? Then negative, you're gonna give me quadrant 3 and quadrant 4 answers. Okay. So that means you have two. And what happens if you got plus and minus sign? Okay. So if you only have plus or negative, then you only have two answers here. But what happens if you have both plus and minuses? Then you will have all four quadrants, all four answers. Okay, so be careful with which quadrant it belongs to. Positive belongs to for sine, only quadrant 1 and quadrant 2. For tangent, positive is only work for quadrant 1 and quadrant 3. And for cosine is only work for quadrant 1 and quadrant 4. That's why you got two answers each. And if you got plus and minuses, then you will get four answers. Okay, so this is how we figure out if they have one revolution. Okay, what happens when you have infinite solutions? Infinite solutions also depends on how many answers you have. Then you just need to add either 2n pi or you add n pi. Okay, when you put 2n pi or n pi means you keep on going infinite times, because 2 pi or plus 360n or 180n depends on if your answer is degrees or radian. So if it's degree, we use 360 or 180n. If it's a radian, we do 2n pi or n pi. So how do we know if you use 2n pi and n pi? It depends on what kind of trigonometric functions we have. It's based on the period. So so for sine, cosine, sine, cosine, cosecant, and secant, the period is 2 pi, so you have to add 2n pi. Okay. For tangent and cotangent, your period in this case is pi, so you will add n pi in this case. So this is based on your what functions we have. So for example, in this case is that if this is sine, so if I want this in the infinite revolutions in this case, your answer in this case will be pi over 6 plus 2n pi. So this is in quadrant 1. And then in quadrant 2, it will be 5 pi over 6 plus 2n pi. And n in this case stands for integers. Means any numbers from 0, 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5. So that means when you add 2n pi or add n pi, it means it goes infinite revolutions here. Okay. So so this is how you write this answer in infinite solutions, and this is how we write your answer in one revolution. Okay. And also majority of your homework and your test, I want everything in terms of radian. So that's why we don't use a lot of this or the 30 degrees or the 150 degrees. So I can tell you that your homework, your test, everything that we do in this class, in this chapter 7.3, everything that we talk about here is gonna be based on radian. So we don't do degrees. So that's why I don't want you guys to worry about the degrees. So make sure you guys know the radian type in this case. So this is the radian type that we have. Okay. So those are what we call as your what we do in this case. Any questions, Gamal?
No.
Next, factoring is one of the big stuff that we will do a lot in these sections. Using identities is also another one that we use a lot. you can also do this. You can also square each side of the equation, because when you solve an equation, you can square them. But watch out when you square this is for the extraneous solutions. So what I mean by you guys know squaring each side of the equation, right? The reason why we square both sides of the equation is because we can use the Pythagorean identity. Okay, because Pythagorean identity can be only used when you see squaring. However, when you solve an answer, you have to check all your answers here, okay, which is a lot of work. So in this case, if you have two answers here, you have to check both answers by plugging this answer, checking into your equations, like normally check your answers here. And you have to check for extraneous solutions. I think we learned that in chapter 5 means a solution that you reject, okay, that rejection. So that's the reason why that this is something that I do not want you guys to do. So this is something that I will say, let's do it at the very end. So that means the last plan. So I will recommend try factoring, try to apply identities. Squaring both sides is something that I do not recommend you to do because of these extraneous solutions. So you might get like 4 to 6 answers or 8 answers. You have to check all 4 to 8 answers by plugging it into the equations, like checking your solutions, and you're checking for extraneous solutions, which is a lot of work. And that's why I do not recommend you do the squaring both sides. Okay. And the most important thing is that you have what we call as a multiple angles. Okay. What is the meaning when I say multiple angles? Multiple angles is where you got your sine or your cosine, your angles is been multiple, like 2x, 3x, or it's been half, like over 2 or over 3. So when you have this, you have to divide and multiply your end results. Okay. So so what we have here is example is when you get something like this. This is only considered as not multiple because it's only 1x. So what happens that if I change this to become multiple, it will look like 3 plus 2 sine 2x equals to 4. So remember, this is the equation that we have to solve last time. Okay. So a lot of students, they solve like what we just did on last time. Okay, I just take here 3, I minus 3, and then I divide it by 2, right? So this is 1/2. And this is where a lot of students get wrong here is they take this 2 and they're going to divide this by 2. This will become sine x. And 1/2 divided by 2 is 1/4. So if you do something like this in my test, you will get it wrong. Okay. The reason why is because if you look at the solving equations, the 2 is actually inside the sign. So we do not do the 2x first. We actually have to perform the arc sign first. So so this is considered wrong. So do not do this in your test. So the right way to do this is you got sine 2x equals to 1/2. And then when you move the sign, it'll become the arc sign of 1/2. And we already did the arc sign of 1/2, which is 30 degrees or 150 degrees, or in radians is pi over 6 and 5 pi over 6. So what we do, the last thing that we do with this 2x that you see here, the multiple angles here, is we will divide all this by 2. So we will get x in this case. So when you divide by 2, you just take this 2 and multiply. So this will become pi over 12. And this will become 5 pi over 12. So this is what happens if you have what we call as 1 revolution. Means your answer goes from 0 to 2 pi, then this is your answer. What happens if you have infinite solutions? So you do need to take this, you'll look something like this. You will get pi over 6 plus 2n pi and 5 pi over 6 plus 2n pi. So for infinite solutions, so we have to divide this by 2. So you have to divide this by 2, right? Last time we did it here. And guess what? You also need to divide the 2n pi by 2. Okay. So if you want this answer in an infinite solutions, then your answer will be pi over 12 plus n pi, because the 2 will cancel out here. And then this one will give us 5 pi over 12 plus n pi. So this is what happens when I ask for infinite solutions. You won't get 2n pi here, and the reason why is because your 2 will be divided because of this 2x here. You guys got what I'm trying to say here? Questions? Anyone?
So the number we divide with is whatever is in front of x.
Mm-hmm.
Okay.
So if it's a 3x, then you divide everything by 3.
Okay.
But what happens if this is not 3x, this is x over 2? So you still do the same thing. You will still get pi over 6 and 5 pi over 6, right? But how do you get rid of this over 2? Now, we don't divide here. What do we do?
Multiply.
So now we will multiply everything here by 2. So it's like solving, equations, right? So now your x in this case will be pi over 3 and 5 pi over 3. Because when you multiply by 2, the 6 goes into 2 3 times.
Would we have to multiply the n pi too?
Yes. So in this case, if you write this in your infinite solutions, then the whole thing here will be multiplied by 2. So you will get pi over 3 plus 4n pi now, because 2 times 2 is 4, right? And this will also give you 4n pi, because again, you multiply your 2n pi by 2. So like solving equations. Anyone have any questions here?
But do we leave the answer just like that? There's like no reduction.
Yes, you depends on the question. If a question asks for infinite solution, then your answer will be pi over 3 plus 4n pi, and 5 pi over 3 plus 4n pi. But if a question is asking for 1 revolution, then your answer in this case is just pi over 3 and 5 pi over 3. You do not need a 4n pi. Anyone have any questions? So that's why this is tough, and the reason why I say this is tough is because there are so many rules here, and you have to follow these rules.
You muted yourself.
So what happened is that when you guys do this, you have to be careful with is that 1 revolution? Is that 2 revolution? Do you have if you have a cosecant, cotangent, secant, you have to flip it to become the reciprocal. And then the next one is if you have like what we call as multiple angles, double angles or triple angles, or angles that divide by 2, then you have to solve as usual, and then at the end you have to either divide or multiply by a number so that x is by itself. So just be careful with this. This is something that a lot of students get headaches here. Okay. And again, we want everything in radian form. Okay. So let's take a look at the first question. Again, the first few questions, they want you in an infinite revolutions. So that's why the question here did not say 0 to 2 pi. So how do we solve tangent x plus root 3 equals to 0? So solving x, anyone know how to get rid of? Which one should we get rid of first? Anyone? Solve for x. Gamal? So we move the √3 over, become what? Tangent x is negative √3. And then what happens to this tangent x? We move over, so become what? The arctangent of it. And then you have to tell me what is the angle or quadrant. Can someone tell me what quadrant makes tangent negative? There are two quadrants.
2 and 4.
Quadrant 2 and quadrant 4. Okay. Can someone tell me what angle make tangent what angle give us √3? Anyone? Grab your unit circles. Remember your unit circles. So look at your y over x. Which one of this angle will give us √3? Hmm?
2 pi over 3.
Huh? So that is 2 pi. Yep. So that will be here. Sorry, quadrant 2, right? 2 pi over 3, and what else? Quadrant 4 also, right? Which is what?
300.
Again, I want everything in radian, so don't give me
Five.
radian. 4 pi over 3, right? No. 5 pi over 3, right? No.
5 pi over.
Yep, sorry, it's 5 pi over 3. Okay. And what do we need to add here? 2n pi or n pi in this case?
N pi.
No, because tangent, the cycles or the period is pi. So in this case, you only need to add n pi. Okay. So don't forget, tangent and cotangent, the cycles is the cycle is pi. So that's why you add n pi here. So this is your answer in this case. So again, this is for infinite solutions here. Anyone have any questions here? Okay, next we will have sine square x equals to 3 cosine square x. Now, usually when you guys solve this kind of equations, we want you guys in one trigonometric form. That means everything in tangent, everything in sine, everything in cosine. So if they give you sine and cosine like this, you cannot solve it. You have to make everything all in terms of sine or all in terms of cosine. So in this case, they are square, so we can use a Pythagorean identity here. And you can change sine become cosine, right, using Pythagorean, or cosine to become sine using Pythagorean. So I'm going to change all the sine to become cosine because I do not need to distribute the 3 later on. Can someone tell me what is the Pythagorean identity for sine square x?
1 minus cosine square.
So you will get 1 minus cosine square. Yep, this is 1 minus cosine square x. So this is back to like solving equations. So because we got square, so we had to make this equals to 0. So I just move all this over to that side. So you will get 0 here. So this, when you move, how many cosine square x do we have?
Two.
No. Forget this is negative.
0.
No, this is the same thing as 1 minus x squared equals to 3x squared. 1 minus x, 3x squared. So what happens when you move over? How many x squares do we have? You should have 4, right? So this will be the same thing. You will get 4 because we are adding cosine square here. That's why you get 4. And then what happens to this 1? It become what? minus 1. So we have to solve this. So solving this is like solving like number 1. So we want to make x by itself. So we move the 1 over back here. So become 1 over 4 cosine square x. And then we divide this by 4. Now we need to get rid of the square. So what you do how you get rid of the square? You have to take the square root. And when you take the square root, you have to give a plus and minuses. So this is where a lot of students make mistake here is they forget to give me plus minuses. Okay. So that means you will have 4 quadrants because the plus will give you 2 quadrants, the minus will give you 2. So every time when you see plus minuses, you will have 4 answers instead of 2. Does someone tell me what is 1/4 when you take a square root of it?
1/2.
You get 1/2. And then we'll move back the, so we are solving this. So x in this case will be the arc cosine of plus minus 1/2. So in this case, you will have 4 answers. The reason why is because of the plus and minuses. So can someone tell me what angle for cosine is 1/2? Half. Unit circle, people. What gives us 1/2 for cosine? 30, 45, or 60 degrees? Anyone? Unit circles? 1/2. Hello?
Is it 30?
So
Yeah,
this
is it
is so cosine 30 degrees is 1/2, and 30 degrees in rad, again I want everything in radian, is pi over 6. So in this case your answer will be pi over 6. So quadrant 1. The next quadrant is quadrant 2, will be 5 pi over 6. Quadrant 3 is 7 pi over 6. And quadrant 4 will be 11 pi over 6. So you will get 4 answers because of the plus minus. The quadrant 1 and quadrant 4 will give the positive. The quadrant 2 and 3 will give the negative. So that's why you got all 4 answers. However, as you know that this one, you want an infinite solutions, and cosine is 2 and pi. So that means every single one here, you have to add 2 and pi. So this is your answer for the infinite solutions. Questions? Yep, come on.
Why didn't you change it to arc cosine the first time you moved cosine to the other side?
This one?
Yeah.
I did. I changed the cosine to arc cosine.
No, the first time you did that when you put it.
The first time. Can you tell me what you mean by the first time?
So in question 2,
Mhm.
it's 1 minus cosine squared x equals 3 cosine squared x, and you move everything on the left side to the right side and combine them. Shouldn't it have become arc cosine then?
No, I'm adding cosine x here to both sides.
Okay.
So this is gone. And then I'm subtracting 1 here.
I got you.
Okay, so I'm not doing the cosine because again, your arc, when you do the arc, you have to do it very end, so that x is by itself, or 2x or 3x, if you have multiples. So be careful. This is normal solving equations here. Okay, so one thing I want to point out to you guys is that when you do the arc sine and arc cosine, make sure you guys know that if you have like 1/2 or or root 3 over 2, they all give you an answer. But what happens if you have arc sine of 2 or arc cosine of -2? Do you guys know what is this answer is? This answer will be do not exist. The reason why this answer does not exist is because if you remember your graph for sine and cosine, your sine and cosine graph is always bounded by -1 and 1. Okay, so if you want to try to figure out 2 or -2, that's above 1 and -1. So that's why you will get do not exist here, because your value is above. It's not in between -1 and 1. However, if it's a tangent, if it's arctangent, then it will give us a value. It exists because tangent graph is not bounded by -1 and 1. Tangent graph is from negative, is all real numbers. This is all tangent. So that's the reason why that when you do the arc sine and arc cosine, if this number is not in between -1 and 1, you will get do not exist. For arctangent, any numbers will go in this case. Okay, and this you have to use a calculator because this is -2 is not in your unit circle. So if you find out that this number that you see here is not in your unit circle, you have to use your calculators in this case, okay, to figure out what is the value for that. And make sure you set this in radian in your calculator, not degrees. Okay, again, everything we do here is radian. Anyone have any questions here? This is tough. This is not easy. Okay. Now we got multiples. So this is what we call as a multiple angles here. Why this is a multiple angles is because if you look carefully, there is a 3x. So if you look carefully on number 1 and number 2, you only got tangent 1x or sine 1x, cosine 1x. So now you got 3x. This is considered multiple angles. And if you do this in my test, you get 0. Okay, so please do not do that. So it's like following orders of operation. You have to, the 3x is inside, so you have to do it very last here. So do not divide by 3. So the first thing, anyone know what to do first if you see this kind?
Further 3.
Calvin, I cannot hear you.
You square the 3.
Yep, so you have to square root here to take care of the square. Okay, so the steps that when you guys do here is first, if you have like positive √3 or 2 tangent, you have to get rid of those negative, you have to subtract and then divide. And then next, if you have a square, you have to square root it. Okay. Third, you move your your sine or cosine. And then the last thing you're gonna do here is if you have 3x or 4x, you have to divide everything by 3 or 4, depends on the So these are the rules, these are the steps that we go over. So this question doesn't have the 2 or the √3, so that's why you do not need to do step 1, but it does have a square root. Do not forget, every time you have a square, so every time when you take a square root, you need a plus minus here. So the tangent 3x that you have here will be plus minus √3. And then the third step is to move your tangent over to that side. So 3x in this case will be the arctangent of plus minus √3. I think we did √3 before, right? On question 1. Can someone tell me what angles is again for √3? For tangent. We did question 1. Is that 30, 45, or 60 degrees?
It was 2 pi over 3 and 5 pi over 3.
It'll be pi over 3 and 5 pi over 3. But unfortunately, that for this question, we cannot use this. Is because you have the plus minus. So you have to give me all 4 quadrants. So pi over 3 is in quadrant 1. And then what is quadrant 2 for pi over 3? 2 pi over 3, right? Yep. And then quadrant 3 is 4 pi over 3. And then quadrant 4 is 5 pi over 3. So this, you have to give me all 4 quadrants. And then because of your, it is an infinite revolution, for tangent, you have to add n pi. But what you give it to me here, class, is not x, is 3x. So what we do? So in order for you to solve for x, you have to divide everything by 3. So can someone tell me what you get when you divide everything by 3? What's pi over 3 divided by 3? So you just multiply this to become 9. And then n pi over 3, you get n pi over 3. So this is for quadrant 1. And then for this, you will get 2 pi over 9 plus n pi over 3. This, you will get 4 pi over 9 plus n pi over 3. And for the last one, when you divide that by 3, you will get 5 pi over 9 plus n pi over 3. So this is your answer for question number 3. Okay, so it's a lot of work. It's not easy. Okay, this is actually a bit more work here. So that's why in my test, make sure you know if you see a square involved, like this case, you make sure you know you will have 4 answers here. Okay, and if you don't give me 4 quadrants, 4 answers means 4 quadrants. If you don't give me 4 answers of 4 quadrants, you probably won't get the full points. Okay, questions, anyone here? Next one is number 4. So question 4, this value is already factored for us. So if this is already factored for us, then we can set this equals to 0 and solve for x. So you get 2 sine square x minus 1 equals to 0. And then you also got tangent square x minus 3 is equals to 0. So in this case, you actually have to solve both of them. So in order for you to solve for x here, anyone know what to do first when you solve for x on question 4 here?
Add 1 and divide by 2.
Okay. And then what you do next? So you get 1/2, right? What's the next thing?
Take the square root of sine.
Yep. And don't forget the plus minus. This is where a lot of students make mistakes. So you get sine x. Can someone tell me what is the square root of 1/2? Anyone know what's the square of 1/2? This is the same as 1/√2. Because square of 1 is 1, square of 2 is √2. Can someone rationalize this?
√2.
Yeah, this is √2/2. Yep. And now we move the sign over to that side, so it becomes the arc sine of it. So how many answers we will get here, class? 4 answers. So can someone tell me what angles give us sine √2/2? it will be pi over 4. So you're at 45 degrees. So your answer in this case is quadrant 1, pi over 4. Yep, quadrant 2, 3 pi over 4. Followed by what?
5 pi over 4.
That is quadrant number 3. And then
7 pi over 4.
7 pi over 4. So again, because of plus minuses, you have to give me all 4 quadrants. And sine, can someone tell me sine is what cycle? Pi or 2 pi?
2 pi.
So in this case, you just put 2n pi. I do not know if 2n pi in your homework on your online homework or 2k pi. If it's 2k pi, 2n pi, the same thing. Okay, I don't know. I forgot what they use for n in here. So some textbook use k, some textbook use n. So make sure you read the question, and the question will tell you, are we using k or n? Okay, they will tell you. So this is only one part of it. So now you're going to do the other part. Can someone tell me what you need to do on this part?
Plus the 3.
So so you add 3 there. So you got tangent square x equals to 3. And then you take the square root of it. You will have a plus minus. And then we move the tangent over. Do we do this already, class? We did it, right? This is exactly what we did in question number 1 and question number 2, right? Number 3, sorry, number 3. Can someone tell me what is this again?
Pi over 3. Pi over 3. Pi over 3.
2 pi over 3 plus n pi. 4 pi over 3 plus n pi. And 5 pi over 3 plus n pi. So how many answers we have in this question?
8.
8, yes. 4 on that side and 4 on this side. You will get 8. Okay. So this is what happens when the question's already been factored for you, like this, and it's equal to 0. So you do not need to factor, you just make them equal to 0 and solve it. Then we have this question number 5. So this kind of questions you will get in my test, number 5, number 6. So please pay attention. So anyone know what to do with question number 5 here? Come on, Kelvin.
Minus square root.
And then?
Divided by 2.
Yep. Now, do you see any square on this?
No.
No. So do not square root it. Can you want to divide by 2 here, class? Can you do this?
No.
No. So please don't do the divide by 2 on the 2x here. That is the n you do, okay? So what you have in this case is negative root 3 over 2. So you don't have plus minus here. So how many answers you get here, class? You will only get 2 answers. Okay. So you move the sign over. So you become the arc sine of it. Can someone tell me what angles give us sine of that angles give us root 3 over 2? If you look at your unit circles. This is supposed to be found in quadrant 3 and also quadrant 4. Because sine is negative in these 2 quadrants. Anyone?
4 pi over 3.
So,
4 pi over 3.
So this is 4 pi over 3 plus 2n pi because sine is that. And what is quadrant 4 is?
5 pi over 3.
Plus 2n pi. Yep, this is your. However, this is all equals to what? 2x. And we are solving for x. So this is the last thing that we do here, class, is you don't divide 2 here. No. You divide 2 at the end here. So once you finish figure out what is the angle, then you divide this by 2. So can someone tell me what answers you get here once you divide this by 2? This will become what? 4 pi over 6, because 3 times 2 is 6, plus the 2 and 2 will cancel, so you just get n pi. Right? And can someone divide by 2 here? What do you get?
5 pi over 6 plus n pi.
Yep. And again, now you reduce. Can we reduce 4, 6? It become what? 2/3, right?
Yeah.
So your answer in this case will be 2 pi over 3 plus n pi. 5 pi over 6 cannot be reduced, so that is your 5 pi over 6 plus n pi. So this is how we do this kind of questions. Yes, as I mentioned early on, these kind of questions will be coming out in your tests on Wednesday. So make sure you guys know how to do this. Pretty much very important. Okay. Now, a lot of you guys, when you do your homework, you always ask, you watch the video, right? Okay, a lot of people, when you do your online homework, you use the watch it button. Now, I want to point out to you guys that when you use a watch it button for this section, you have to be careful, because when you do the watch it button, all your majority of the watch it button videos is only good for 0 to 2 pi. But so if a question is asking like number 5 or number 6, and if you just watch it and they say, oh, your answer is pi over 3 and 5 pi over 3, if you put it down, it will be wrong. The reason why is because 0 for 2 pi means it's for 1 revolution. So if you do question 5 or question 6, this is for infinite revolutions. You have to do the n pi. Okay, so a lot of my students will ask me that in your homework, saying that, why, David, I go watch it and I got this answer and I don't know why they marked me wrong. The answer, I will reply back to you, well, the answer that you give to me is only for 1 revolution, but the question is asking for infinite revolution. You're missing the n pi and the 2n pi. Okay, that is the reason why that, so when you watch it, be careful. Don't look at the answer. Oh, this is my answer. Sometimes your homework instruction calling you to for 1 revolution, and sometimes they want infinite. And your watch it button that you see over there is not necessarily match or consistent with the questions asking for. Okay, so the domains and stuff. So be careful with it. That I can tell you. All right, and anyone knows do question number 6? What should we do first?
You add and you divide by.
So you add √2 and divide by 2.
And you in the arc line on the other side.
Yep, so you do the arc cosine of it. So you move the cosine, become arc cosine. This is what when you this you get √2 over 2, right?
Yep.
How many answers you get for this case?
2.
2, because it's only positive. So can someone tell me for cosine, positive in what quadrant?
1 and 4.
1 and 4. And what is √2 over 2 for cosine? What angle?
Pi over 4 and 7 pi over 4.
And since this is asking for infinite revolution, so you have to add what? 2n pi. And again, class, what you have here is for what? Not x. X over 2, right? So how do we get rid of this over 2? So x is by itself.
Times by 2.
So you have to take all this times 2. So what you get when you multiply by 2 here? So what is pi over 4 times 2? You will get 2 pi over 4. 2n pi times 2 become 4n pi. Okay. This you multiply by 2, you will get 7 times 2 is 14 pi over 4. And then 2n pi times 2 become 4n pi. Okay, so one is for this and one is for that. And then you reduce. 2/4 can be reduced to become 1/2. 14 over 4 can be reduced to become 7 over 2. Okay. So reducing is the last thing you're going to do. I think you guys know how to reduce fraction. So this will be your answer for question number 6. Anyone have any questions here? Questions? Now, the rest of it, 7, 8, 9, 10, is a little bit different from 1 to 6, is because now they want you to write in the interval of 0 to 2 pi. Now, does anyone know what's the difference between a bracket and a parenthesis here? Anyone? What is bracket stands for and what is parenthesis stands for, if you see this? Bracket means it includes 0. And parenthesis means what? You exclude 2 pi. So that means that if you get your answer, you know 0 and 2 pi is the same thing, right? 0 and 360 is the same thing because you go through one revolution. So that means that you only need to take 0. You don't take 2 pi. Okay. So if you get your answer 0 or 2 pi because they are the same numbers, because you go one whole full revolution, then you only take 0. You exclude 2 pi in this case. Okay. So this is the meaning when you see a bracket and a parenthesis. Now, anyone know how to do question number 7? Also, this is also coming up in your test on Wednesday. There are 2 different trigonometric functions here. One is sine and one is cosine. You cannot solve it. So what we do here?
Change the sign.
I'm sorry, Calvin. Something with a sign, I heard.
Change sine squared.
To become what?
1 minus cosine.
Yep. So so what we do in this case that we will change sine squared to 1 minus cosine squared using Pythagorean, and the rest you just drop out, drop it. So 2 will be there, equals 2 plus cosine x. So now what you see on this new equation, everything is in terms of cosine. Then we can solve it. So first thing first, the 2 have to distribute. So you get 2 minus 2 cosine square x equals to 2 plus cosine x. So this is again back to your normal solving equations here. So since you got square, you have to make this equals to 0. So either you move all this over there or you move the other one. So let's move all this over there. And when I say move, means this 2 will be subtracted 2. This cosine will be minus cosine x. Okay, so we are not doing the arc in this case, like what Gamal tried to figure out. We don't do arc cosine here because we are trying to make this equal to 0 by moving all these terms to the other side. Now the 2 and the negative 2 will cancel. So what we left in this case is negative 2 cosine square x minus cosine x. Now, does anyone know how to factor this? Anyone know what's in common here? Can we factor out something in common here?
X squared minus x.
This looks like, yeah, this looks like negative 2x squared minus x. Yeah, what can we factor out here?
Negative x.
So what can you factor out here? Negative cosine x. So what you get? When you take this negative cosine x from here, you get a positive 2 cosine x. Because you distribute this to this, you get the negative 2 cosine square x. What happens when you take out negative cosine x from negative cosine x? What you get? You get a positive 1. Because if you take this times 1, you get negative cosine x. And what we do in this case is, this is a refactor, so we make this equals to 0. So negative cosine x equals to 0. And then this equals to 0, so cosine x equals to negative 1/2. That's solving your x. Now this negative you can move over, but as you know that when you move over, the 0 doesn't have negative, so you can ignore the negative. Now we move the cosine over, so it becomes arc cosine of 0. Does anyone know what is arc cosine of 0 is?
Two pi and pi.
So every time when you get 0, 1, or negative 1, your answer in this case is no longer on 30, 45, 60. So if you get arc cosine of 0, 1, or negative 1, for sine cosine especially, you will get in the x or y axis, means either 0, pi over 2, pi, or 3 pi over 2. So for arc cosine of 0, your answer in this case will be pi over 2 and 3 pi over 2. Okay, and then we do the same thing on this. So x in this case is arc cosine of negative 1/2. And what is that going to be? So you also got two answers here. Use your unit circles. This is quadrant 2 and quadrant 3. Cosine is negative in these two quadrants. Anyone know what angles give us negative 1/2 for cosine?
5 pi over 6.
And
11 pi over 6.
no, 11 pi is positive. 7 pi over 6. Okay, don't forget it's 1 and 3. 2 and 3, not 4. So this will be your answer in this case. And you notice this answer is different from the answer that we have over here. And the reason why is because we do not need to have 2n pi's to add on it, because your question here is only asking for 1 revolution. Okay. So this is your answer. Questions you guys have?
Could you repeat the thing you said about getting arc cosine or arc sine of 0, 1, or negative 1?
You just need to look at your coordinates. You got your unit circles, right, with you?
Yeah.
So so this is 1, 0. This is 0, 1. This is negative 1, 0. 0, negative 1, right?
Yep.
This is 0 degrees, pi over 2, pi, and 3 pi over 2, right?
Yep.
So cosine is what value, x or y? X or y, the cosine?
X.
X. So which one of these gives us x value that is 0?
Pi over 2 and 3 pi over 2.
That's my answer. You got it, Gamal?
Yep.
Okay. So that's why the 0 and 1 and negative 1 is always, because either you get 0, 1, or negative 1, depends on your x or y. This is again for arc cosine and arc sine. Okay, arc tangent doesn't work. Questions?
If it was tangent, it would be undefined.
45 degrees.
Okay.
Pi over 4. Don't forget 1. If it's 1, arc tangent of 1 is actually 45 degrees.
Okay.
Pi over 4. Yep. Make sure you guys know this is something tricky. A lot of students, this is only the one that I'm showing you here is just for sine, arc sine, and arc cosine. For arc tangent, make sure you look at the y. Remember, you got one coordinate, say y over x one, right? That is the tangent one that you look for. Yep, this is tough. Let's do number 8 here. Sine x minus 2 equals to cosine x minus 2. Now, this question number 8 that you see here is they are not the same, and we cannot use Pythagorean identity here. The reason why, anyone know why we cannot use Pythagorean identity here?
It's not squared.
It's not square. Now, then you learn a method that, if you want to make it square, we can square both sides. But this is the thing I tell you, if you square both sides, you have to check your answers for extraneous solution, which is a lot of work. And the reason why we square both sides is because we can use Pythagorean. So what we do here is, this is a trick, so we don't do this. So first thing is we just add 2 here first to get rid of the 2. So what you left in here is just sine x equals to cosine x. Okay. Now, so what we do is we don't square both sides because we have to check all these extraneous. So you can if you want. So we don't want to do it because we don't want to check our answer. So what do we do is we divide. So we will divide both sides by cosine x, because once you divide by cosine x, do anyone know what is sine x divided by cosine x is?
And
so we can use the quotient identity here. So this is actually a tangent x. And you know what cosine over cosine is actually is what?
1.
Is 1. Now we can move the tan to become arctan. So x in this case is an arctangent of 1. Can someone tell me what angle give us 1 for tangent? Quadrant 1. This will be, so in your unit circles, you're looking for y over x.
pi over 4.
And what else is also positive? What quadrant is also positive for tangent?
3.
3. And what is pi over 4 in quadrant 3 if you look at your unit circles?
5 pi over 4.
So this is your answer here. And you do not, so this, when you check it, it's going to be work. You don't have any extraneous solutions. But if you square both sides, you will get to check. You will get like 4. You got to get more than 2 answers, because remember when you square, you take a square root. You got 4 answers. 2 of them is extraneous. The other 2 is the real solution. So that's why you have to check them, and which is tedious, because you have to plug this into here and see if they're equal. Then plug 5 pi over 4 into x, see if they're equal, and then plug the other rest of it, and you find these 2 will be the equal. The other 2 will not be the same. It's work. So that's why I try to avoid squaring both sides. Okay. The next one we have is number 9, 2 secant square x plus tangent square x minus 3 is equals to 0. Now again, we got 2 different trigonometric functions here. So we cannot solve this. So in order for you to solve this, you have to change everything in secant or everything in tangent. So which one you prefer, secant or tangent?
Secant.
So we want to change everything in tangent because we are familiar with tangent, because a unit circle have tangent. If you do secant, you have to do the reciprocal. So that means we have to change this to become tangent. So can someone tell me what can we do with this to change to tangent?
One plus tan square.
So using Pythagorean identity, 1 plus tangent square x is secant square x. So what you need to do is the 2 you have to distribute, and then after that you have to tangent square x minus 3 behind equals to 0. They all will be dropped, so that we just use that. So distribute the 2, you will get 2 plus 2 tangent square x, and then plus another tangent square x minus 3. So this is like solving equations and combine like terms. So how many tangent square x we have now?
3.
3 tangent square x, and then this is minus 1 because 2 take away 3 is -1 equals to 0. Now, since you do not need to factor this one because it's only got 1 tangent square x, so you just solve like usual. So how do we get x by itself? Anyone?
+1 divided by 3, and
then take the square root. Don't forget the plus minus. So what we have in this case is tangent x is plus minus square root of what here? 1/3, right? This is the same thing as 1/√3. Can someone tell me what is the rationalize this denominator? What you get?
3.
So you get √3/3. And don't forget the plus minus because of the square. Now you move the tangent over. So you will get arctangent of this. Now, how many answers will you get for this kind of questions?
4.
You will get 4 answers due to the plus and minuses. Okay. So now look back at your unit circle. Find the one that has y/x. So what angles when you do y/x, which one of this will give us √3/3?
Pi/6.
So quadrant 1 is pi/6. What else? Quadrant 2 is 5 pi/6. Quadrant 3 is
7 pi/6.
7 pi/6. And the last quadrant, quadrant
11
4.
pi/6.
So this is your answer in this case. You guys all right here? Tough. Or you guys can do this. Make sure you start working on your homework here. So this is mostly this is something that you look, oh, this one looks easy, right? I really want you guys to try it because I'm doing mostly all the work here. You guys just either copy down or just, oh yeah, I can follow along. Try to do one questions on your own and see what you think. So I'm gonna want you guys to do question number 11 on your own now. Go ahead. Question 11 on your own. 2 sine square x, because this kind of questions will be come out in your test on test 3 on Wednesday. And again, they wanted this in 0 to 2 pi. Okay, they want this in 0 to 2 pi. In the test, I also can tell you in the test, I also want it in 0 to 2 pi. That means in the test, you do not need to give me that plus n pi or plus 2n pi. Okay, so the test is also asking you for this. Go ahead and try this question on your own. And also attendance. Don't forget to put present in your in the chat room for attendance. Anyone know where to start on this question?
Change the sign. And be 2 parentheses 1 minus cosine squared x plus 5 cosine.
Wait. Yes, Kevin, you're way too fast. Yes, we're gonna use Pythagorean to do this. Why we cannot use Pythagorean? Can we use Pythagorean on this one? Can we use Pythagorean of cosine x?
No, because it's not square.
Yes, we cannot use this because this is not square. Okay, so make sure you guys know Pythagorean is only for square. The rest, you just bring it down. So the 2 is over here, plus 5 cosine x equals to 4. So you notice that this new equation that you get, they're all in terms of cosine. Good news, means you're in the right track. All right, I want you guys to move this 4 over, right? So subtract 4. So this will become -4. You need to make it equal to 0. This is because the reason why is because it's a quadratic. So we have to make it equal to 0. Factoring will be the one that I want you guys. So what you get? Distribute the 2.
2 minus 2 cosine squared x.
Then the rest you just plus 5 cosine x. And the 4 remove become negative 4. All right, combine like terms, what you get? Five cosine x. What you get?
Minus 2.
Now, usually this is the hint I always tell my students. Every time this is where you begin to factor. So the hint for factoring is we do not like your leading coefficient negative. Okay, so every time when you want to factor, we do not like this to become negative. No. So we always want him to become positive. It's easy for us to factor. So for us to get rid of this negative, I just multiply this whole thing by negative 1. So what happens, or switch all your signs. So that means your you get 2 negative become positive, and positive will become negative. So this is usually the something that I always tell my students when you guys factor. We always want the leading coefficient to be plus. Okay. Now you need to factor. Anyone know what's a factor for this? So 2 cosine square x is 2 cosine x times cosine x. Anyone know how to factor positive 2? What times what is 2?
1.
1 times 2. And you need to get a negative 5. So this both must be negative. So how do you know if your factor is correct? You just FOIL it out. If you FOIL it out, you should get back him. 2 times negative 2, you get negative 4 cosine. And then negative 1 times 1 cosine, you get negative 1, you get a negative 5. So this is a correct factor. And you have to make this equals to 0. Right? So what happens to here when you make it to 0? You get cosine x equals to 1/2. And here you get cosine x equals to 2. And you move the cosine over, become arc cosine. 1/2. You do the same thing over here. You move the cosine over there, become arc cosine. So can someone tell me using the unit circle what is this answer will be? You got 2 because it's positive. Quadrant 1 and quadrant 4. Anyone? Pi over anyone? Cosine, what is 1/2? Cosine 30 degrees, 45 degrees. It's always 30, 45, or 60. That's it. Anyone?
Pi over 3.
Okay, cosine 60 degrees or pi over 3. And what else? This is quadrant 1. And quadrant 4?
5 pi over 3.
Now, does anyone know this one? What happens to him? Arc cosine of 2. This fellow is DNE. So your answer is these 2 answers. Now, why this is DNE does not exist?
You can't get
Because 2 is above 1 and negative 1. Remember that cosine only bounded by the range of negative 1 to 1. So anything that is above or below negative 1 and 1 is no good. So 2 is above 1, so no good. So it does not exist. So your answer in this case will be this 2. Questions, anyone? Okay. So we're gonna end today's Zoom here. So if anyone have any questions, please let me know. Don't forget your test is Wednesday. Tomorrow is Wednesday. Your online homework is due tomorrow by midnight, so 7.2 and 7.3. And again, when you guys watch 7.3 homework, be careful. Your watch sheet sometimes is in one solution, but the question is asking for infinite. So, they use n, that's good. So they use n. So like these kind of questions, when you see n, they ask for infinite. But when you watch this, I just show it to you. Oh, this give. So if the question is giving you n pi, means that it's infinite. Sometimes I do not know why that when some students watch it and they give you the other type of solutions, means the one revolution instead of infinite revolutions. So that's the reason why that I would recommend you guys to be careful when you watch this kind of homework questions. Make sure you guys know. So mostly it's following along the notes that we did. The first 5-10 questions are infinite, and then after that they will do a one revolution. Maybe I'll watch. Let me see this one. Maybe this is the one that might have. Oh, this is correct, because you don't see any n pi in this case, so or 2 n pi, because this is in one revolution. So I just want to point out, this is in one revolution. Please don't write your answer as 2 n pi or n pi. The one that is above that you see the n, make sure you use the n pi or 2 n pi. You guys clear what I'm trying to tell you guys?
Yeah.
Because I got a lot of students who complain about me about this. I was like, well, you need to know this already. Okay, something very basic. All right, so I'm going to stop here. Anyone have any questions before we end the Zoom session?